we have polygons. The technical definition of a polygon is a union of segments that meet at the endpoints such that at most two segments meet at one point and each segment meets exactly two other segments. It has to have at least three sides and none of the sides meet at more than one place. So this polygon is not a polygon. Okay? Or I don't know, something like this, because there's more than one side meeting at one place. So it's not, these are not polygons. Basically, shapes. Okay? Now you have special kind of polygon, and these are called convex polygons. And convex polygons exist so that all of the diagonals are on the interior, which we'll need to know what a diagonal is for that to work. But basically, a convex polygon looks like this. These are the shapes you're kind of used to. And a non-convex polygon looks kind of weird. Yeah. So with a convex polygon, you get sort of like an open shape, right? And with a non-convex polygon, it looks like it's like a folded. Or yeah,
that's when I think of the convey, which is the opposite.
So yeah, so they look bent a little bit or like caved in. Okay, so a polygon with congruent sides is equilateral. Congruent sides, squares, right? All the sides are the same length. Rhombus, an equilateral triangle. So if all your sides are the same length, you're an equilateral polygon. An equiangular polygon has all of the angles the same. Square, rectangle, equilateral triangle. Okay, because a square has all 90 degrees, a rectangle has all 90 degrees, these are all 60. And then if you're both, if you have equal sides and equal angles, you're called regular. That would be a square, equilateral triangle. And there's others. I'm just pentagon, regular pentagons, there's regular hexagons. A stop sign is a regular octagon. All of the sides are the same length and all the angles are the same. So stop sign. Okay. Now the diagonal is the segment that connects two non-consecutive vertices. So I'll show you what that looks like in a second, but we talked about how you can tell if it's convex or concave is that all the diagonals are on the inside. So I'll show you what that looks like in just one moment. Okay, so diagonals connect from one corner to another. A triangle has no diagonals because there's no way to connect the corners without actually being a side. And a diagonal is not a side. If you have a parallelogram, you have two diagonals. Pentagon, 5 diagonals. Hexagon, you have 3. Okay. So these are diagonals, and now these are all convex because the diagonals are on the inside. I'm going to back up for just 1 second and I'll come back to this. If you look here, my non-convex, to connect these two, I would have to exit. So I have a diagonal that would be outside. So this is why it's non-convex. To connect these two, I'm going outside. Sure, I have some inside, but I have one outside. So that makes it non-convex. When I'm on my convex shapes, there are no diagonals outside. Like if I were to try to go outside, I'd be doing like some big loopy loop. That's not a diagonal. We have a theorem that tells us how to figure out the interior angles of a polygon. And basically, if you draw all the possible diagonals from one, oh, I guess I missed out on several. That's not 3. I lied. I forgot about these. Yeah, it's not 3. It's 9. I lied. Sorry. I forgot about those. Okay. If I draw all of the possible diagonals from one vertex, okay, so I make triangles, and yeah, my lines aren't perfect, so they're not actually making triangles, but you see how I make triangles? And I have 1, 2, 3, 4 triangles. And each triangle is 180 degrees each, right? So if I have 4 times 180, that's going to tell me how many angles are in this total polygon. So that's going to be 720 degrees. Okay. Now, is it practical to always have to draw all of the triangles? Like if you start getting really multi-sided shapes, you don't want to draw all these triangles trying to find out how many angles there are. So they created a formula, which we'll do in 1 second. Some theorems. We have the polygon interior angle sum theorem, which takes this information but turns it into a formula we can use. So you take the number of sides, subtract 2, and multiply it by 180. And if you look, we had a hexagon. That's 6 sides. It gave us 4 triangles. 6 minus 2 is 4 times 180. So our formula to find the number of sides in any polygon that's convex, it has to be convex, is 180 times n minus 2, where n is the number of sides. So let's say I wanted to do a pentagon. That's 5 sides. So I do 180 times 5 minus 2. So 180 times 3. So 540 degrees. And we talk about exterior angles. We're not talking about all of the exterior angles. Okay? We're talking about all of the exterior angles going in one direction. So if I draw this line out, I don't then draw this one here also. I keep going kind of around in a circle. And the angles that that makes will add up to 360. If I draw a triangle, okay, same thing, going in one direction, these angles will all add up to 360. Okay. Okay, now we can use this information to find some other formulas. So you have the measure of each interior angle in a regular polygon. So if I know it's a regular polygon, which means all the angles are the same, that's my formula. So I find out the total number of angles total measure of the angles, and then divide it by the number of angles. Number of angles and the number of sides is the same. So 5 sides, 5 angles. This again, though, only works if you're talking about a regular polygon, which means the angles and the sides are the same length. And then if you have a regular polygon, you can find the measure of each exterior angle, again, regular polygon. So if this is a regular hexagon, I can take 360, divide it by 6, and find out that each of these is going to be equal to 60 degrees. Or this triangle, 360 divided by 3, each of these is 120 degrees, if that was a regular triangle, regular polygon. So the number of sides determines its name. You need to know these. Don't know. And I would recommend this one also. And this one. Okay, but the names are based off of tri meaning 3, quad meaning 4, penta meaning 5, hex meaning 6, hept meaning 7, oct is 8, non is 9, and dec is 10. That comes from Greek or Latin, I'm not sure which. Anyway, you need to know the first 10. Well, sorry, not the first 10 because there's no 1 or 2. The first 7, or 8 rather, which are 3 through 10. And I would recommend knowing 12 and 20. These are just because they're fun, and I thought you might like to know them. And we're going to find the measure, the sum, so the total, of the interior angles of an 11-sided figure, which is a hendecagon. So we're going to use that formula. So it's 180 times 11 minus 2. 180 times 9, and that is 1620. So a hendecagon has a total angle measure of 1620. How many sides does a heptagon have? Okay, so we're going to do the same thing. So heptagon has 7 sides. So 7 minus 2. So 5. And 180 times 5 is 900? I think. Yeah, 900. Problem, we're given the total angle. We want to find the sides. Okay, so that's our formula, right? So if I take and plug in the total, I can find out what n equals. Now we're going to go a little differently than we would normally do with algebra, which would be to distribute the 180 and then go from there. We don't have to do that because we know it's going to divide by 180 because it's been multiplied by 180. So we're going to do dividing by 180 first. So you get n minus 2 is going to be equal to 7. Add 2 to both sides. And you get that this is a 9-sided figure. Okay, so if you want to do this without algebra, you're going to take your total, divide it by 180, and then add 2. A total angle measure of 1980, we want to find the number of sides. Do you guys want to do the algebra or the not algebra? Yes. Were you watching? Okay, we'll do it without algebra. So 13 sides. Ask you to find each interior and exterior angle of a regular pentagon. Okay, pentagon is 5 sides. All right, so we're going to go back, and we're using these formulas. This is each interior, this is each exterior. So for the interior, we're using 180 times n minus 2 divided by n. That's the formula. So that's 180 times 5 minus 2 divided by 5, which is going to give us 540 divided by 5, which is 108 degrees. So each angle inside of a regular pentagon is 108 degrees. For the exterior angles, it's 360 divided by n. So since it's a pentagon, it's 360 divided by 5. So each exterior angle is 72. Now we can check this to make sure we're correct, because an interior and an exterior angle will add up to what? 180. So 108 plus 72, 180. We're good. Problems like this next one, where you have to find each interior angle from this quadrilateral. So to figure that out, first I have to know how many angles total are in a quadrilateral. So first we find out the total, which is 180 times n minus 2, and a quadrilateral has 4 sides. So it's 180 times 2, which is 360. So this whole thing is going to be 360. All right, once we've found the total, we can say, okay, each of these is 90, right? Because they're marked. So what I'm going to have is 3x plus x plus 90 plus 90 will equal the 360. So 4x plus 180 will equal 360. I subtract 180 from both sides. 4x is going to equal 180. If I divide by 4, I'll then know x. X is going to equal 45. That's this one. So now I just need to find 3x. So I'm just going to say 3 times 45. So that one's 135. And those will all add up to 360. So I'm going to do 180 times 8 minus 2, or 180 times 6, which is 1080. Okay, to find how many sides a 2340 will have, do you prefer if I do the algebra way or the not algebra way? Algebra? Okay. So 180 is equal to 2340. Divide by 180. And I'm going to get that n minus 2 is equal to 13. So add 2 to both sides, and we have 15 sides. Okay, here we're going to find both the interior and exterior angles for an octagon. So I do 180 times n minus 2, sorry, 8 minus 2, divided by 8. Well, I already know that an octagon is 8 sides, so that I know that this total here is 1080. Right, because I did that already. So it's 1080 divided by 8, which is 135. So each interior angle is 135. And each exterior angle is 360 divided by 8. And 360 divided by 8 is 45.
So 45 would be the exterior.
Yeah, this is the exterior, this is the interior. And then finally, we have a 17-sided figure. We're going to find the interior angle sum. So 180 times 15, and that is 2,700. How many sides does this have? Well, let's count. Yeah, 5. 1, 2, 3, 4, 5, right? So it's a pentagon. So I have 180 times 3. So 540 total degrees. Okay, each of these will add up to 540, but you see how these are both 3x plus 14? So I have to do that twice. Okay, so that's twice. And then I have a 2x, another 2x, and 142. All of that together will equal the 540. Okay. So 3x, 6x, 8x, 10x. And then I have 14, 28, plus 142, so that's 170. Okay. Subtract 170 from both sides, and you're going to get 10x is equal to 370. So what does x equal? 37. Now this is 2x. So 2 times 37 is 74. So this is 74, this is 74. And then this is 3x plus 14. So I have to do 37 times 3, which is 111 plus 14. So each of these is 125. Okay, so now we have all the interior angles. And you'll notice I had to do that because it said find the measures of each angle, not find x. So just be really careful with that. Now for this one that you're going to do on your square, you just have to find x. Okay?
And that's the 180.
Yeah, because first you have a 4-sided figure, so you figure out your total number of the angles, and then you solve for x. And while you do that, I'm going to write down this.